It's best if you have the review out while we're going over these. All right, number 3. So real quick, Taylor, the biggest thing is we didn't really, do you understand the direct and indirect, or the, I'm sorry, direct and inverse variations? Do you understand the difference between the two?
Yeah, I do.
Okay. So what one do you want? 3?
Yeah, I just want to make sure I did it right.
Can I do 4 instead? Because it's more of a tricky one because of fractions involved in it, but it's the
Yeah,
same
actually,
process.
4 would be better.
Okay. And then 3 is a little easier because it's not so fractiony. So here's what I would do is I would say, okay, when they tell me, as soon as they see the word inversely, it varies inversely, I know this is my formula. And since they gave me a y, I'm going to put it in here. And since they gave me an x, I'm going to put that in over here. And my goal is to find this constant, so I got to get it by itself. So I times by 6, I times both sides by 6, and I end up with 24/5 is my constant. So if they ask me for the equation, I go y equals 24 over 5 over x. The problem is you won't see this as your answer. So we got to look at this and tailor what would be some way. That's the process of finding k. I found it, but you won't find this as the answer choice. What does this fraction bar really mean?
Divide.
So what's another way I could write that? Instead of writing it like this, with this being the divide, how could I write this same exact thing but make this a divide sign?
It would be 24/5 divided by x.
Yes, ma'am. So remember how I told you in math, we change the way things look sometimes?
Mm-hmm.
Because you won't, like I said, you won't see this answer choice. But when you see it like this, what do you know you can do?
Keep, change, flip.
Because we don't divide fractions, right?
Mm-hmm.
And so this becomes 24/5 times 1 over x, and then we will see 24 over 5x, and that is one of my answer choices.
Oh, okay.
So
Thank you.
remember, math is all about changing the way things look. So this was really technically the answer, but they don't like it written like that. So they just changed the way it was written by thinking of this as a division, which then I can keep, change, flip, and then I can get to this answer. That's what we do all day long. We manipulate numbers.
All right.
I'm great at manipulating numbers. I'm terrible with people. I don't have that kind of bone in my body. Some people are really good at it. But man, I can manipulate some numbers. What else? Questions? Ooh, I know you guys.
Over number 13.
Oh, you're so close to the one I need to go over.
14?
Nope. The other way.
12.
Yeah, because 12 had something happen that I wasn't sure if we needed to cover it because it doesn't really talk about it in the examples in the book. And so it is coming up on the test. So I want to make sure we cover it. And it's something that I kind of talked a little bit about, but I didn't go into great detail of it. So I'm coming back to it. So we graphed before we talked about things canceling out. And so we never had an example of what happens in 12. So if I factor 12, actually, I'm going to go through, I'm getting ahead of myself. First thing we want to do is get asymptotes. That's the first thing. If someone ever asks me to graph it and I see I have an x in the denominator, I got to get my vertical and my horizontal asymptotes. Now, I'm going to attack this in 2 different ways. I'm going to go, okay, where do my vertical and where do my horizontal asymptotes come from? And then I'm going to look at the form they give me and see which one I want to get. Well, when I look at this, I see that this is actually in standard form in both of them. And that's good for horizontal asymptotes. Because in a horizontal asymptotes, I need to compare their powers. So both of these have a power of 2. And if you remember, I did like top is bigger than than bottom, or if top was smaller than bottom, or if top is equal to bottom. I guess I can do this. Top is greater than, top is less than. And this is referring to the powers of, or the degree of each one of the top and bottom. And what happened is there were 3 cases, and when the bottom was the same as the top, you took the coefficients of each of them and divided them. 1 over 1 is 1, so y equals 1 was my horizontal. I attacked my horizontal asymptote because they gave it to me in standard form, and your horizontal comes from standard form. Next, I'm going to try to get my vertical asymptotes because the asymptotes really dictate the shape of the graph. And so what I'm going to do is I'm going to actually factor both the top and bottom, because this is where something new is happening. This has different signs. This says bigger one is positive, 2 numbers that multiply to 5 but subtract to 4. That'd be a positive 5 and a negative 1. This I should see real quick that that's a difference of squares. And when I do this, I realize that my x can't equal positive 5, and I realize that x can't equal negative 5. And when before, these were considered asymptotes. But what I'm going to show you today is there's actually a new thing called a hole. And what happens is holes and vertical asymptotes come from the same spot. They both come from denominator being 0. But what happens is one of them cancels out and one of them doesn't. The one that is canceled out creates the hole. The one that remains is a vertical asymptote. So for this one is x equals 5. That is actually going to be our vertical asymptote. So we have a vertical asymptote at x equals 5. We actually have a hole at x equaling negative 5. And what that looks like on my graph is 1, 2, 3, 4, 5. This is still a vertical asymptote. 1, this is still a horizontal. But when I make my x and y chart, which I would make x and y, I would plug in numbers to the right and to the left of the vertical asymptote. So I would plug in a 6 and get a number out. I'd plug in a 7, get a number out. And then I would plug in the other side of the asymptote. So I might try a 4. I would maybe try a 3. So those first 2 would get me the points on this side of the asymptote, wherever they fall. These 2 would get me on this side of the asymptote, maybe up there, maybe down here. And either way, what would happen is, let's see if I plug in a 4. 4 minus 3. 4 minus 1 is 3. So that's my top. 4 minus 5 is a negative 1, so negative 3. So if I plug in 4, I get a negative 3 out. Wow, what's going on? And so 4 would be negative 3. So this side's going to look like this, is what it's going to look like. But what happens is when it gets to 1, 2, 3, 4, 5, when it gets to negative 5, there's literally a hole like that. And then the graph continues on. So this is a hole. This is a vertical asymptote. This is a horizontal asymptote. So when they cancel out, that's where holes are made. When they don't cancel out, that's when vertical asymptotes are made. So even if I gave you a problem like this, what happens is vertical asymptote, horizontal asymptote, or hole. Okay, those are the 3 things that can happen. Well, let's look at the horizontal asymptote first. The horizontal asymptote comes when I compare the top power to the bottom. Well, I know if I multiplied this times this, it would get me x squared. And I know on the bottom, I only have an x. When the top is bigger than the bottom, there is no horizontal asymptote. So I don't have to worry about a horizontal asymptote. Vertical asymptote only happens when the denominator becomes 0. Well, there's a problem here. my x can't equal -1, so I know this is either going to be a vertical or a hole. And when this cancels out, I realize there's no vertical asymptote either for this question. There's only a hole at -1. And so then I would make my x and y chart, and I could plug in numbers, and remember this would simplify to y equals x plus 2, which is, that looks linear, and actually it is going to be linear. If I put a 0 in, x for 0, you get a 2 out, so 0, 1, 2. If I put a 1 in, you get a 3 out. If you put a 2 in, you would get a 4 out. And so it's making that line like we thought would happen. However, if I plugged -1 in, when I plug -1 into here, -1 plus 2 is 1. At -1, 1, there's going to be a hole. So if you notice the difference, I made these dots like colored in, basically saying they can be this. And here I made a very pronounced open circle because that tells the person right here there's a hole, which means the graph kind of goes through it, and then here it kind of skips over it. Boop, it's like it jumps it, and then it keeps going forever. At holes, you're going to notice the graph doesn't change its shape. It's linear, it jumps over this spot, and then it continues linear. When we have asymptotes, you might see the graph going like this on this side of the graph, on that side of the asymptote, but then over here you're going to see it doing this. On one side of the asymptote, it can completely change shapes to the other side of the asymptote. Whereas a hole, it's the shape, there's a hole, and then it continues. I mean, you might have a parabola, there might be a hole here, and then it continues being a parabola. So holes, the shape continues, just jumps over that one spot. Asymptotes, it might change shapes completely. Like we might have two asymptotes, and out here it looks like this shape, and on here it might look like a parabola, and out here it might look like that. Notice the shapes can change once I go over asymptotes. Holes, the shape stays the same. It just jumps over and continues what it was doing. Does that make sense? Hello?
Yes.
Questions on holes or asymptotes? All right, what was the other question? 13 you wanted me to do?
Yes.
So, Isabella, is it because it's got that into the fourth power?
Yeah, I was just confused the entire thing.
All right, so you're going to pretend like this is just really like when you have n to the fourth and then it goes to n to the second here, you can actually pretend like this is like x to the second and this is just x. So we can factor it the same kind of way that we've done in the past, meaning this says same signs, this says they're both negative. I need two numbers that multiply to 24 but add to 10. That would be 6 and 4. But then here, instead of just putting an n, right, because n times n would just get me n squared, how about an n squared? Because then n squared times n squared gets me into the fourth. Then this times this gets me a negative 4n squared, and this gets me another negative 6n squared, and together those make a negative 10n squared. Does that make sense?
Yes.
So my top, now you can't do that if this was a 3. This has to be like a 4 and a 2, and or you could do like a 9 and a 3, because then the front one can be a third, this one can be a third, right? So this times this, no, I don't mean that, I mean 6, sorry. This times this would get me to that, and then when I do this and this, that would get me my middle term of being a third power. I hope that makes sense. So you kind of can do any combination as long as this is half of that. You can kind of treat it the same way we've done in the past.
Yeah, it makes a lot of sense.
So this should be n squared, we said minus 6, and n squared minus 4. Now you should have a problem with this one because you should recognize that that is a difference of squares. So I'm actually going to break it out. And then down here, you should recognize that this gets me to n squared minus 6 and then n squared minus 3. And when I do that, n squared minus 6, n squared minus 3, before I do any canceling out, I need to see my my exclusions. So what makes this 0? If you can't see it, remember, just take it to the side and set it equal to 0. Add 6, add 6. N squared equals 6, square root. You put the square root sign in there, therefore you must put the plus or minus sign, and so you should get n equals plus or minus the square root of 6. That's one of the exclusions. And then you do the same thing for the other bubble. Oop, that was supposed to be a 3, not a 6. Which should be n squared minus 3 equals 0. Add the 3. N squared equals 3, square root, n equals plus or minus the square root of 3. So these things, there's actually 4 answers that are my exclusions. Square root of 6, negative square root of 6, which is not imaginary. Remember, that negative is outside, not underneath. So that's not imaginary. Square root of 3 and negative square root of 3. And then since I have my exclusions, now I can cross crap out. This cancels out. This would be your final answer, but if you look, you don't see that final answer. They actually distribute this back or turn it back into this. And so sometimes we break something out and we realize it didn't cancel. So we go back to its standard form. So n squared minus 4 would be what this top would turn into over n squared minus 3. And no, the n squared do not cancel out. You can't cancel out the 4 and the 3. Nope, none of that can cancel out. That would be my final answer, including these 4 exclusions. Who asked for that? Izzy, Isabella?
Yeah, me.
Did that make sense?
Yeah, I made a lot more sense.
All right. Questions? This is your chance to ask me any questions from this review to get ready for what you are going to be doing tomorrow, which is testing on this.
Can you do 10?
Mm-hmm. All right. Who asked me for number 10? Is that Nina? Starting to recognize your guys' voices a little bit. So Nina, what did they ask you for in this question?
Um,
Do you have it pulled up?
Yeah, it asked you for the horizontal asymptote.
Okay. What form do I like to find horizontal asymptotes in?
Standard?
Yes, ma'am. What form are they both in?
Standard?
So it's not a question, right? They are in standard form. Standard form is the highest power all the way down to the lowest, right? It's not factored form. There's no bubbles or anything like that. It's standard form, yes?
Mm-hmm.
Okay, so when I'm in standard form, I have case 1, I have case 2, and I have case 3, right? If top is greater than bottom, it says something. If top is less than bottom, it says another thing. And if top and bottom are equal, it says a third thing. So first off, which case do we have? And you need to memorize these.
It says top is greater than bottom.
Because this is a 5, this is a 2, top is greater than bottom. So we have case 1. What does it say in your notes when top is bigger than bottom?
I think it said y equals 1. Or no asymptote.
It's the no asymptote one. When the bottom is bigger, it's y equals 0. When they're equal, it's the one where you divide. That's just kind of memorizing. Does that make sense and help, Nina?
Yeah, it does. Thank you.
questions?
Is there math homework tonight?
Yeah? Get ready for the test. You should be going over this review again. Asking yourself questions. Why did he attack the problem the way he did? What's he looking at? Why does he like standard form for this one? That kind of stuff. Know why you're doing stuff, guys. Don't just do it. It will make life much easier. Know your why.
Could you go over number 14?
Sure, you can help me though, okay?
Okay.
Wait, I did 14.
You did 13.
I did 14. This one? This one you're referring to? If I can get to it, where is that? This one is 14.
Oh, okay. I thought that was 13. That also
Sorry,
13.
that was 14. Do you want me to do 13?
Yeah, that's fine.
All right, Isabella. You can
Yeah.
you can stay unmuted.
Okay.
What's the first things that I need to attack whenever I see, like if I'm going to graph this, what's the first things I need to think about?
The Y?
These guys shape my graph.
Mm-hmm.
So what's the biggest thing we've been talking about basically this entire chapter? They're new. Sound like a cuss word.
They sound like a cuss word.
The asymptotes.
Yeah. Okay.
We have to find, those are going to be the, whenever someone asks you to graph these things, you got to know. Do you know what asymptotes are?
A little bit, yeah.
Okay. What is confusing you on them?
Just how you, like, get them, you know, like.
Okay, so vertical asymptotes are always found from making the bottom 0.
Okay.
That's where they're always found. So the first thing I'm going to do is I'm going to say, what makes this denominator 0? Well, that means you might have to do this. You see how I'm taking the bottom and making it equal to 0. And from algebra 1, I should be able to do, this is called a two-step equation. I should be able to get x isolated, which means all by itself. And I realize that x is not allowed to be 4/3.
Mm-hmm.
So x equals negative 4/3 is my vertical asymptote. Now, I know that it's not a whole because I can't factor this or this any further, which means if nothing's going to cancel out. So since I can't cancel anything out, I know it's a vertical asymptote. My horizontal asymptote comes from 3 cases, the rules that I've been talking about throughout this day. We look at the power of the top, we look at the power of the bottom. What is the power of the top? What is x to the power of the biggest one?
4?
Nope, the top. The power is the exponent. So like, that's the power of 2, this is the power of 3, this is a power of 4, this is a power of 1. So what is the power of the top?
2? Do
You see this right here?
Yes.
The power is that number up there. There is nothing written. If there's nothing written, it's understood to be a 1.
Okay.
What is the power of the bottom?
1.
And the rule for that is if they were the same, you take the leading coefficient, which is now the 2, right? Do you see how vocab is so important?
Yes.
In this right here, I have what I call a power. I have a degree. That's all referring to this number. There's also another number here, which is called the leading coefficient. If I'm saying look at the power and you're looking at the leading coefficient, do you think you're going to be able to do this math very well?
No.
That's why vocab is so important in understanding it. And a lot of this stuff is from previous years, but it's okay as long as you ask questions and we can go over it. And that's why I'm talking to you specifically, because I can kind of see where you're having a hard time. And I'm trying to help you see, like, okay, this is the power. This is what I'm saying is top bigger than bottom. Well, 1 is equal to 1. And when the powers are the same, you take the leading coefficient, which is -2, the leading coefficient of this one, which is -3, and divide them. And that, a negative and negative make a positive. So 2/3 is my horizontal asymptote. And horizontal asymptotes are always y equals 2/3. -4/3 would be here's -1, here's -2, -4/3 would fall in there. Here's 1, 2/3 would fall somewhere around here. And then I make an X and Y chart. And I now plug in numbers that are on this side of this thing over here. And then after that, I'm going to plug in numbers that are on this side over there. So here we go. My first number to this side of the asymptote would be 1. So I'm going to plug in 1. The next number would be 0. I'm sorry, -1. And the next number after that would be a +1. So when I say that, those are the X's I'm plugging in to right here.
Mhm.
So -2 times -1 is 2. All I did is I put a -1 in here. -1 times -2 is 2. Plus 4 is 6. So I have a 6 in the top. -1 times -3 is a +3. And +3 minus 4 is a -1, which gets me to a -6. So -1 1, 2, 3, 4, 5, 6, -6. If I plug a 0 in, all this is going to turn to 0. All this is going to turn to 0, and 0 plus 4 is a +4. 0 plus or minus 4 is a -4, and 4 over -4 is -1. Finally, I put a 1 in the place. 1 times a -2 is -2. -2 plus 4 is +2. Did I do that right? And then over 3 times 1 is -3. And -3 minus 4 is -7. So it'd be somewhere right in here. And eventually this thing is going to get like this. And we know it's going to chase the asymptotes. Now I need the other side of the asymptote. So if this is -1, then I'm going to use -2, -3, and -4, and I'm plugging those in. Does that make sense?
Yeah, that makes a lot more sense.
And you would find the outputs when you plug those in. So you plug in -2, get an output, put it here. Plug in -3, get an output, put in -4, an output. It's probably going to be somewhere like this. Homework questions.
This isn't necessarily a homework question. I just forgot. Is this due today or tomorrow? I have it done. I just forgot which
It's
day.
due today. It needs to be in there.
Okay.
Questions on homework or your test review?
Mr. Martin, can you put our homework in the portal?
Your homework is to get ready for this test, bud. That's what you're doing. Does anyone have questions on any more? That's all we have today.
Could you do 5?
All right, so y equals 10 over 9x. So before I do this one, I want to talk about the different forms. So, and then we'll come back to this. If I said y equals 5x plus 10 over x minus 1, this is in a different form than if I give you this one. Right? Hopefully you can see the difference. You know, this is some kind of equation over another one. This really has this plus 2 back here. So that, I mean, that's a huge tell. There's nothing back here. This is just a fraction over, you know, something and a fraction, nothing else behind it. Whereas this one has a fraction, but it also has this. The reason I'm pointing this out is because these two forms have different ways of finding my horizontal and vertical asymptote. When I'm doing this one, my vertical asymptote is still going to come from whatever makes the denominator 0, which in this case is going to be x equals 1. The same thing for this one. My vertical asymptote is going to come from what makes this denominator 0, which again is 1. But my horizontal for this one is going to come from my cases, where I'm going to look at the power of the top, which is 1, the power of the bottom, which is 1. And so since they're the same, I'm going to do 5 divided by 1, which is going to be y equals 5. Why? Because this was a different form than this one. My vertical or my horizontal asymptote for this one is going to come from right here, which is y equals 2. These are two different forms, and we need to know the difference. The reason I'm bringing that up is because I'm going to look at number 5. Which form do I have? Do I have the top one that I just did, or do I have the bottom one?
The top one.
I have the top one, which means my vertical asymptote is still going to come from what makes the denominator 0. And what makes the denominator 0 for this case is 0. So x is not allowed to equal 0. And then my horizontal asymptote, I'm going to look at this, and my power of my top technically is 0, because anything to the 0 power is 1. And then you should know that 1 times 10 is still 10. So I can kind of add this in here, and then that tells me my top is 1. My denominator power is, my top is 0. My bottom is 1, which means my top is smaller than my bottom. And every time the top is smaller than your bottom, y equals 0. So these are the most important things. I got to get my asymptotes before I even try to graph this thing. They're going to dictate the shape of the graph. Once I got my asymptotes, I'm just going to make a y equals, especially since it's multiple choice, I'm not going to make much of a graph. I'm just going to get the left side of it and the right side of it, and then I'm going to pretty much have what graph it should be. And I'll make sure on the test that they are not similar. If one is similar, I'll delete it. So maybe you only have out of A, B, and C answer choices. I'll make sure only one is there that would actually be accurate. And if I have to, maybe I'll make it out of A and B. But you should be able to get this graph by plugging in. So I'd plug in just to the right of it, which just to the right of it would be 1. So I would be, don't worry about this anymore. This would basically be 10 over, and then 9 times 1 is 9, so it would be 10/9, which I know is just a little bit bigger than 1. I don't really care too much about where it is. I just care that this is going to be the shape of the graph. And then if I put a -1 in, I would get a -10/9 out, which would be something like this. And again, so I'm going to be looking for the graph that's going to have a part of it here and here in these asymptotes. And I'll probably be able to see, oh, that's answer A. If I wanted to graph it better, I would just pick more X's and Y's. More X's, and then plug in and figure out the Y's. Questions? All right. You should be ready.